As we said earlier, the introduction part is concluded. Now we are going to start the actual content of Signals and Systems syllabus as per Osmania University norms and regulations. Let us start. Let us start. Now, Unit 1 is divided into two subparts. First one is called Signals part. Second one is Systems part. Now, regarding the part 1, Signals module is concerned. Here, we discuss some important operations on signals. Actually, operations on signals can be in two ways. First, with respect to amplitude. With respect to amplitude. The second one with respect to time. Second one with respect to time. But as far the syllabus is concerned, just we are going to discuss operations on signals with respect to time. With respect to time. Now, again just look at the first part of this Unit 1 contains operations on signals. Operations on signals can be on two types. First one is on amplitude point of view. Second one is on time point of view. Now just we are going to discuss signals with respect to time point of view. After that, I will tell you how amplitude point of view the signals will be modified. First, as per the syllabus is concerned, now time modified signals is given. That's why I am discussing this part now. Next one I will discuss with respect to amplitude. Now just look at operations. What kind of operations can we make on signals with respect to time? This is called, first one is called time shifting. Time shifting. The second one is called time scaling. Third one is called time inversion. Time inversion or time reversal. Both you can make it time reversal. Just look at time shifting, time scaling and time reversing. Again, students have to understand the concept of these three. Just look at, in among these three different operations, only one word is same. That word is called what? Time. Time, here you can write shifting. Third one, time scaling. Fourth one, time reversal. Now just look at, this is the way of understanding the operations on signals, operations of signals with respect to time modifications. So these three important points now just we have to discuss under the concept of operations on signals. Now we are going to discuss the first part of time shifting. Time shifting. As said earlier, here signal means x of t. The representation of shifting or scaling or reversal, all these three have been on only on XOY plane. That is called a graphical representation. That is t and x of t. Horizontal axis is t, vertical axis is x of t. This is the way. Just students have to remember this point very thing. What is time shifting? Now just look at, we have to make a graph like this. This is t, this is x of t. This is 1, 2, 3, 4, 5, etc., etc. This is -1, -2, -3, -4, etc., etc. This is the origin center point. Shifting can be either right side shifting or left side shifting. There will be no shifting on the vertical axis. This point students have to remember. Shifting means only on the parallel axis, not on vertical axis. So now for this purpose you have to make it. You have to write a note point, note. What that note you have to make? Shifting is only on which one? Parallel axis. Only on parallel axis. Shifting cannot be on vertical axis. Now this fundamental point just you have to learn. Again I am telling, shifting will be only on either this side or this side. The center of these two axes is called what? Origin O. Now what do you mean by left? What do you mean by right? Here the time starts with 0. From 0 it moves from 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9. Linearly it is incrementing up to which one? Up to infinity. Now come this side. From 0 to -1, -2, -3 means what? It is linearly degrading. -1 to -2, -3, a little bit increment operator. In C programming, Java, how you make it? Plus operator, incrementing. So just it is up to -infinity. So here T belongs to the limit of which one? -infinity to infinity. Between these two one, T can be any time. It is a numerical number. T is always measured in terms of seconds. Just look at here, signal systems here, T is measured in seconds. Don't go for milli, micro, nano, pico like that. It is only seconds. Here time is measured in terms of seconds only. Now just look at, just we started the concept of shifting. But in the shifting, there is no mentioning of either right shifting or left shifting. Just they mentioned shifting only. So now students have to make it like this. So shifting, write it, round it up, draw two arrows. This is, one is called left shifting. Second one is called right shifting. These things just we have to make it very immediate step. So shifting can be how many ways? 2 ways. Again I am repeating this one. Shifting will be always on parallel axis. There is no question of vertical axis. The reason I will tell when I will start the second property. Now just look at, we are going to shifting property. Now just look at, there is a graph. This is T. This is x of t, 0. Before going for shifting operations, just we have to discuss a physical day-to-day life operation example. There is a train at a station. This is called amplitude. One more point. The pieces, the part on vertical axis, in mathematics we call it as height. But in electronics we call it as amplitude. In electrical engineering we call it as DC component. Students have to remember, concept is same but titles are changing. In mathematics we call it as height of the function. In signal systems we call it as amplitude. The same number we call electrical engineering as DC component. DC component, everything will be discussing in the next sessions. DC component. Now this is a signal. Don't use the word signal. For your understanding purpose, it is a train at Sikandrabad station. This train, what are the limits of this train? Belongs to starting point 1. That means starting point, end point of the total train. Length of the train is 4 units. In that way you understand. It has to reach that a particular station at 8 p.m. it has to reach it particular station by 8 p.m. But it reached at 10 p.m. Again, don't take signal into consideration. Here I am giving you a direct day-to-day operation of a train example. The train at Secunderabad station. For example, what is the length of the total train from 1 to 4? That means 4 compartments like that. It has to reach some station, either Bangalore or Vizag, what it may be. It has to reach by 8 p.m. The correct time is what? 8 p.m. 8 p.m. There is a correct time. Correct time of arrival. But unfortunately, the train reached. But unfortunately, the train reached at 10 p.m. Again, just look at, this is the duration of the signal, length of the compartment. Look at the words, length of the total train or compartment or duration of the signal. It has to start at Secunderabad. It has to reach some Bangalore at 8 p.m. But because of some problems, it reached 10 p.m. The actual time is 8 p.m. It reached 10 p.m. That means what word we use? Later advancing. The train is late by how many hours? 2 hours. That is called what? Late. Train is late by how many hours? 2 hours late. Again, just look at. Observe the numerics here. 1, 2, 3, 4. 1, 2, 3, 4 are numerics. This part is on which one? Right side of the graph. That is called on the positive axis. Towards this, all these are positive numbers. So we call it as a positive axis. Positive axis. The train is supposed to reach at 8 p.m. but unfortunately late by 2 hours. That is 10 p.m. So here, what word we use here? We use the train is late. Late. Why it is late? Look at 8 p.m. is expected, but reached 10 p.m. What do you mean by that? From whether it reach 8 or 10, but from 1 to 8 and 1 to 10, how the graph rises from 1 to next step 2 to 3, 3 to 4, 4 to 5, or like this 1 to 2, 2 to 3. Look at, observe my movements in the forward direction. In this way I am moving. I reach the station by what time? 10 p.m. So here the late was what? 2 hours. 2 hours. So now whenever regarding the positive axis is concerned, we use the word late. It is a late. Late by how many hours? Some T0 hours. Some T0 hours. Generally late means what? Time loss. So we use the mathematical notation of C of T minus T0. X of T minus T0. Just look at T0. What is the actual graph? The actual graph is X of T. Because of late arrival, we use which notation we used? T minus T0. Just look at. How many units? 2 units. Regarding this graph is called concern. In place of T0, we use 2. T minus T0. That means what? Towards the positive axis, like this. Towards the positive axis, it is called what? Right shifting. Right shifting always indicates what? Delay. Right shifting always indicates delay. Now, this is the right shifting. So now, here, if you take this one, the graph is X of T. Regarding this, we have to make it as X of T minus 2.